Let's try another example. So let L be the length of one side of a square and A be the area of a square. A, define the dependent and independent variable, and B, sketch a graph of the situation. So what are we talking about here? Let's see. Let L be the length of one side of a square and A be the area of a square. Okay. A, define the dependent and independent variable. So keep in mind, as a reference, X comes first, followed by Y. Agreed? So what comes first in this case? Independent, the parent, right? Well, let's say L. You must know the length first before you can find the area. Agreed? So therefore, in this case, the X representative is L, the length. Dependent is the kids, which comes second or after it, right? So therefore, area comes after you know the length. So the area must be the dependent variable. Okay, so B, sketch a graph of the situation. Let's start with a quick sketch though of what we're talking about. So a rectangle. We know that a rectangle has a length and a width. You can always reverse the values of the W and L depending on your point of view, right? So where the L is could be a W, and where the W is, you could have an L. That's your point of view. Keep in mind, it's still the same. It works. So area of a rectangle is length times width. Okay, but we're talking about a square, right? So area of a square. Well, let's say our width is referenced as S. Well, our length must also be referenced as S, meaning they're both the same side, or S for same side. Well, we can say area equals side times side, or side square. Or another way to see this, just for reference so we can keep the L, is that the length is the same for both sides, right? So area equals length times length, or length squared. Okay, so now let's do a quick sketch. So there's our X and Y axis. And from before we stated that the dependent variable is the kids, so it must go on the Y-axis representative, or the Y-axis, which is the A in this case. And the L is the independent variable, the parents. So it must go on the X-axis, which is the representative, in this case is the L. Okay, independent and dependent. Independent L, dependent the A. You must know the L before you can get the area. Okay, just random locations or random values. Let's assume it's increasing by 1. If we go 1 times 1, we get 1. 2 times 2, we get 4. And 3 times 3, we get 9, etc. So this is just a basic rough idea so that we can see if it worked or not. So yeah, it looks like it gives us a fair representation of input. You need to know the length, and then you get the area as your output.